Alright students, today our learning objective is area of a circle and the sectors. So we're going to start by remembering what the definition of area is. An area is, since way back in actually elementary school, you learned that the area is the amount of space inside of shape. Okay, so let's write that down, the amount of space occupied by shape, so the space inside a shape. And in this case, we're going to be talking about circles, so inside of a circle. Okay, we measure this in units squared. So if you're not given a unit like yards or feet or miles, you just use the word units and make sure that if you're talking about area, it's going to be units squared. The sector of a circle, that's kind of like a piece of pie or a piece of pizza. It's a slice. Okay, so it's going to be the region that is bounded by the two sides of the angle, so the two radii, by two radii. And remember, radius plural is radii. Radii of a circle. So it's bounded by, if we're talking about this section right here, we're going to bound it by this radius and this one. And their intercepted arc. So it's going to be here, here, and this intercepted arc here. So it's talking about this piece of pie here. Okay. This is also measured in units squared. And you might want to put over here a slice of pizza to remind yourself that it's just a portion of the area of a circle. Slice of pizza. Or a slice of the circle even. Okay? Next, area of a circle theorem. Well, it's just the same as the formula that you've known all along. The area of a circle is pi times the square of the radius. Okay? So here, area is going to equal pi r squared, where r is the radius of the circle. Alright, so let's say that I have this formula, but I know what the area is, but I don't know what the radius is, and they want me to find the radius. So let's go over here and manipulate this equation here. When I'm looking for just the radius, looking for the radius. Okay, well, if you notice here, I have area equals pi r squared, and I want to get r by itself, so I need to take this pi and move it over to the other side. So I divide both sides by pi. So over here on the left, that's going to be the area divided by pi will equal, the pi's cancel out over here, leaving me with r squared. But I don't want r squared, I just want r. So that means I have to take the square root of both sides. So that means that the radius is equal to the square root of the area divided by pi. Well, what if they asked me for the diameter? Okay, because in this picture you see a radius and then you see the whole thing, the whole diameter here. Okay, so if they're looking for the diameter, then all you have to do is just, since the radius, here's a radius and that's a radius, it's just two radii, so you double the radius. So the diameter will be this radius times 2. So 2 times the square root of the area divided by pi. All right, now let's move on to area of a sector theorem. Just like the last set of notes, 11.4, where we discovered the length of an arc, it was a ratio, a portion of the circumference. Well, now this is a portion of the area, so we're going to say that the area of the circle, the area of the sector, APB, of sector APB, so they name it with this angle here, the letters that bound it. So area of sector APB over the entire area of the circle is going to equal the measure of this intercepted arc, remember the degrees, over 360. Or they've manipulated it to just say that the area is going to equal the measure of the arc over 360. That gives you your portion size times the area of the whole circle. Okay, so now let's take this and manipulate this as well. Just like we did on the lengths, we won't have as many, but just like on the previous lesson, we changed this formula around. So let's say we are looking for just the area here. So I'm going to write over here, looking for the area. And all I know is I know the area of the sector, okay, and I know the measure of an arc, but that's all I know. Okay, so what I do, if I'm looking for the area of the circle, then I'm going to start off with this, and I'm just going to put AS for area of sector is equal to the measure of arc A of the arc, whatever arc it is, over 360, and then that's going to be times the area. I'm just going to write the word area, times area. Okay, so to get area by itself, I want to get rid of this ratio, this fraction here. So to do that, I want to multiply both sides by the reciprocal of this. So I'm going to take this side here, multiply it by 360 over the measure of the arc, and that's going to cross cancel. And whatever I do to this side, I have to also do to this side. So I'm going to multiply this side by the same thing, which is 360 over the measure of the arc. Okay, so when I clean this up and flip it around, I'm going to have area is equal to, and I'm going to spell that out again, area of the sector times, multiply straight across, so it's going to be times 360 divided by the measure of the arc, whatever arc they give me. Okay, so that's how you find it right there. Okay, next page. So here's some examples. Now on this one again, if they don't tell me to round, I have to give the exact answer. So here, if you look at this one, find the area of a circle with radius 9. They didn't tell me to round, so I want an exact answer here. Find the area of a circle with diameter 10 inches, exact answer here. So again, that answer is going to be in terms of pi. So up here at the top, add exact answer means in terms of pi. And what that means is that pi will be in the answer. Now here they told me to round to the nearest hundredths, round to the nearest thousandths, and then down here they say round answers to the nearest tenth. And so all of these answers will be rounded. Alright, Up here we're going to start with the area formula. Always write down your area formula. Area equals pi r squared. Plug in what you know. So that means that that's going to be pi times 9 squared. And only the 9, when you're plugging this into the calculator, you have to be very careful. Only the 9 is raised to the second power. So that's going to equal 81 times pi, and that's going to be centimeters squared. And remember, don't plug this into the calculator because they didn't say round. So they want an exact answer. That means pi is part of the answer. Next, find the area of a circle when you're given a diameter. Okay, well first I have to find the radius. You know that the radius is equal to the diameter divided by 2. So that's going to be 10 divided by 2, which is 5. Then I know that the area is equal to pi r squared. So that means that that's going to be pi times 5 squared. And when we write this, folks, remember that the number always goes in front of the symbol. So that's going to be 25 pi, and that's going to be inches squared. All right. On the next one, that's the one where we want to find the radius. So if we look at our previous page, radius is going to equal the square root of the area divided by pi. So if we start there, that's just going to help us a little bit. Make it go a little quicker. Plug in the information that you know. So the radius is going to equal, that says 14 pi square meters. So that's going to be 14 pi meters squared over pi. And in this case, look what happens to the pi's. If you have one on top and one on bottom, they cancel each other out. So this one's going to be the square root of 14, and then the square root of meters squared, that's just meters. So now we plug it into our calculator and round. So remember, the squiggly equal sign means approximately, so you need to use that. And second square root 14, close your parentheses, is going to be approximately 3.74165737, but we want to round to the nearest hundredths. That means 2 decimal places. Next to it is a 1, so that means I do not round up. So that's going to be 0.74 meters. And this is meters because it's a radius, and radius is not meter squared. It's just plain units. Okay, number 4. Find the diameter of the circle, and they give me the area, round to the nearest thousandths this time. Okay, so remember, folks, that the diameter, when I'm looking for that, I just multiply 2 times the radius. So here, diameter is going to equal 2 times this formula, area over pi. Okay, so plug in what I know. That means that that's going to be 2 times the square root of 201 feet squared over pi. They say round to the nearest thousand, so I'm going to put this into my calculator. And I'm going to show you how to put that into your calculator. You're going to say, you can leave the 2 to the very end and just plug in this, get an answer, and then multiply by 2, or you can plug in 2 parentheses, second square root, 201 divided by second, and then the pi symbol, but you have to close your parentheses here, otherwise you will get the wrong answer. So, and then notice how this parentheses is closing the one inside the radical. You now have to close it again, because if you have 2 open parentheses, you need 2 closed parentheses. So enter, and then here I am rounding to the nearest thousand, so that means 3 decimal places. So use your squiggly marks. And it's going to be 15.99. And do I put a 7 or do I round up? So I look over here, it says 5, so that means I change that 7 to an 8. And that's going to be feet. Alright, the next one. On the next one, it says find the areas. Notice that S right there, areas of the sectors. Folks, I have two sectors. Just like I had two different kinds of arcs, I have two different kinds of sectors. I have a minor sector here, okay, and I have a major sector here. So if I'm looking for the minor sector, okay, then that's going to be the arc. Remember our formula. That's going to be the arc over 360 times the area. Okay, so it's going to be 63. There's your arc, 63 over 360. That gives me my portion. And then I'm going to multiply that by the area. Now the area I don't have yet, but I know that my radius is 5, and I don't have a label, so that means that I'm going to use the word units. Okay, so pi r squared, so that's going to be 5 times 5 is 25, so that's going to be 25 pi. Okay, now I plug this into my calculator, and I get so here, you put this in parentheses, that's going to be 63 divided by 360, and then parentheses 25 pi, close parentheses. So I type it in just like you see it. Enter, and I get this big long decimal, but they want me to round to the nearest tenth, so that's going to be about 13.7, and again, this is area, so I don't have a unit, so that's going to be units squared. Okay, so that's for the minor sector. Now I have to go back and find the major sector. But before I do that, I have to know what this major arc is. So remember, to get that, you take 360 and you subtract 63. So 360 minus 63 is 297 degrees. So this arc over here is 297 degrees. So I put 297 over 360, and I multiply it by the area, which is 25 pi. Okay. Again, I'm going to plug that into my calculator just like I see it. Parentheses, 297 divided by 360, close parentheses, and then parentheses 25 pi. Oops. Okay. Now enter. Alright, I give a big long decimal, but I went around to the nearest tenth. So that means that this is going to be 64.8, and again that's units squared. Alright, almost done. On this next one, it says find the area of the circle. So I'm going to go to my previous page, and remember we've already manipulated that formula, so I'm going to use this here. Area is equal to the area of the sector times 360 divided by the measure of the arc. Okay, so the area of the sector, they tell me, is this right here, 6.4 yards squared. That's the area of the sector. I'm going to multiply that by 360 and then divide that by the arc, that's the degrees, and that's going to be 80 degrees. When I plug this into my calculator, it's going to be approximately, because I'm going to round it, let's see, that's going to be 6.4 times 360. I hit enter, and then divided by 80. So I get, it's not actually, it's a terminating decimal, so you don't have to put the approximately. Since it's terminating, it's going to be equal to 28.8, and they gave me a unit. It was yards squared. Okay, so that's an exact answer because it's a terminating decimal, rounded to the nearest tenth. Okay, finally, this shape down here, we've got a triangle and a semicircle added together. So I want you to write area of the shape is equal to area of the triangle plus the area of the semicircle. Okay, write down your formulas for this one. So the area of the shape is equal to base times height divided by 2 plus semicircle, the area of it is going to be half of the circle. So that's going to be 1/2 of pi r squared. Alright, so plug in what I know. Area of my shape is going to be the base, which is 7, times the height, which is 4, divided by 2, plus 1/2 of pi times the radius, and we don't know the radius yet because that's 7, but we cut it in half to get 3.5 squared, and that would be my radius. Now when you're plugging this in, make sure that you only square the radius. Okay, so I'm going to clean this up a little bit. This right here, 7 times 4 divided by 2, that's going to be 28 divided by 2 is 14, plus, it's going to be half of pi times 3.5 squared. So that's 2.25. Now, okay, watch this, folks. If they don't tell me to round, they did, but if they don't give me any instructions about rounding, then this is going to be my exact answer. I take that 12.5 and I divide it by 2, and I get 6.125 pi. So I can't add these together because this doesn't have a pi symbol. So this is my exact answer here. And after you plug this into the calculator, you're going to round it, and it's going to be approximately 33.2. Look for your label. They gave me feet, so this is going to be feet squared. And that is it for our notes 11.5.